Hello. Over the next few minutes, we will be discussing the integration of microgrid technology into real estate development in order to ensure a sustainable and prosperous future. This innovative approach to urban development is environmentally sound, preserves the infrastructure, and is also financially and technologically viable. Specifically, a tri-generating combined cycle microgrid will be incorporated directly into a theoretical mid-sized development consisting of three 32-story residential buildings and one 57-story commercial tower. The main components of the microgrid is a combined cycle electrical generating plant where the exhaust from two natural gas-powered turbines is used to power an additional steam generator to increase efficiency. The energy provided by this plant is heavily supplemented by renewable energy provided by wind turbines and solar panels incorporated into the buildings from the design stage, and additionally, the exhaust steam from the power plant would provide heat, hot water, and air conditioning to the development, significantly reducing costs and environmental impact. The need for this approach is apparent as the world's population continues to grow. In 50 years between 1965 and 2015, the total population of the planet has grown from 3 billion to over 7 billion people, an increase of over 200%. More significantly, the urban population has grown by over 300%, from 1 billion people in 1965 to over 4 billion today. Today, nearly 55% of the world's population lives in cities. Significantly, much of this population is increasingly concentrated in megacities. Some of the largest, shown here, have seen population increases of over 2,000% over the last 50 years. This trend is only expected to increase, as by the year 2035, cities of 30 million or more will be common. The allure of the metropolis has never changed. People are drawn to high-paying jobs, diverse cultural experiences, and the ability to network with others, all seeking a better life. However, this constant inrush of humanity invariably strains the local infrastructure, displaces neighborhoods, and harms the environment. Take, for example, a typical block in Manhattan, filled with brownstones, small apartment buildings, and neighborhood businesses. While quaint and appealing, this block cannot handle the constant influx of new New Yorkers, so development has to proceed. Properties are bought and demolished, and construction rapidly begins. Floor by floor, level by level. Soon, 4 new gleaming towers arise, 3 32-story residential units, and a 57-story commercial building. Altogether, over 1,800 new apartments are added, as well as 300,000 square feet of retail space and over 2 million square feet of office space, all providing jobs and opportunities, but at a cost. This typical size development will draw over 180,000 megawatt hours in power a year off the grid, with just one development out of many adding almost 0.5% to the electrical load of the entire city. Additionally, generating this power, heating the buildings, and providing basics like hot water will generate an additional 140,000 tons of greenhouse gas carbon dioxide emissions annually. Now suppose the identical development were built in an integrated fashion, where a generating station is incorporated based on 2 8-megawatt natural gas burning generators, with the exhaust feeding a 1-megawatt steam generator, increasing overall efficiency to over 50%. The exhaust steam would then be generated throughout the development, building by building, providing essential services, including building heat, as well as hot water. Also, the exhaust steam would provide air conditioning through absorption chillers, therefore eliminating peak electrical demand. Additionally, over 400 1-kilowatt wind turbines and 1,800 standard solar panels would be incorporated into the building design. Power from renewable and non-renewable resources would be sent through batteries, balancing the load and ensuring grid neutrality. As an added bonus, especially in the cold Northeast, the now spent steam would be sent back through the buildings and used to de-ice the sidewalks, after which it would be condensed and economically recirculated. The result is the identical development of 1,800 apartments, 300,000 square feet of retail space, and 2 million square feet of office space. However, absolutely no load would be added to the grid, 24/7, 365 days a year. Additionally, greenhouse gases would be cut nearly in half. There are additional costs involved in implementing this design. Based on United States Energy Information Agency averages, the plant itself would cost $16.8 million and would involve annual costs for natural gas to run the turbines. However, the design has inherent recurrent savings, as no additional fuel is needed for heat, hot water, and no power is needed for air conditioning. At most, the design would use only 20% more gas than a traditional building would and draw no power from the grid, while generating nearly $4 million a year in additional revenue. There is also a great deal of support available to implement the various technologies used in this plan. The Federal Department of Energy strongly supports microgrid and renewable energy technologies through grants and loan guarantees, while the Environmental Protection Agency also strongly supports the use of renewable energy, and the Housing and Urban Development Department has programs to support the incorporation of energy efficiency into affordable housing. Each state also strongly supports such innovations, with support in New York State coming in various forms from the New York State Energy Research and Development Authority. Also, major power companies such as Consolidated Edison are heavily invested in innovative energy-saving designs, and there are many private foundations such as the Rockefeller Foundation, the Packard Foundation, the Hewlett Foundation, and the Kresge Foundation who also support such innovations. To sum up, an integrated approach to real estate development based upon a microgrid is technologically viable and based on mature technologies. It is also scalable, since the grid can be sized to literally any combination of residential, commercial, industrial, or public use facilities, with efficiencies only increasing with size. Additionally, the microgrid can also be expanded and sized to include customers outside the development, ideally providing critically used facilities such as schools, hospitals, or other emergency response centers with clean and uninterruptible energy. Equally importantly, this plan is economically viable and profitable, as the electricity generated and the steam are revenue streams in and of themselves, and the novelty of an eco-friendly development is a selling point. Finally, and perhaps most importantly, integrated development is socially responsible. It allows for the expansion of cities without straining existing grid infrastructure, and also provides for expansion that is environmentally friendly. Perhaps most importantly, the additional revenue from the microgrid, along with the reduced operating costs and large amount of public and private support, would allow for a truly affordable development. A development that would not only serve incoming residents, but also provide affordable housing and good jobs to current residents, people who are often displaced during development. We would like to thank the following for their help in producing this video. Siemens AG for providing endless technical data and answering numerous questions. Grid Market LLC for providing real-world annual energy profiles for the buildings used in the model, HOK Architects for freely offering input on design possibilities, Thornton Tomasetti Engineering for generously discussing the details of microgrid design and implementation, and also Pitta, Bischoff, and Del Giorno for regulatory insight and providing numerous introductions. Thank you for your time, and we hope you found this brief presentation thought-provoking and informative. Please feel free to contact us at the email address below.